Cool. All right. It is 3 p.m. So let's put up our picture of what we're going to be doing. So here we have an image of our project for today. So this is, we're going to be doing some basic 2D dungeon generation. And so what I'm going to be doing with this is piggybacking off a project that I did a while ago along with the other members of the content team at Unity called 2D Roguelike, where you made like a little tiny 2D roguelike game over the course of 13 videos. And if you're interested in that, you can check it out on unity3d.com/learn, and the package is on the asset store. So we're going to use the artwork from that and a couple of scripts. And of course, this theme of dungeon generation is very much inspired by the roguelike genre. I'm a big fan of that genre, and it's sort of, a lot of people have been getting into it lately, so I thought it would be a fun topic to talk about. Now, something that I'll say at the top here is that there are so many different ways to approach generating a dungeon, and they're really, or just generating any content procedurally. So it really varies based on your game, what you're trying to achieve, the feeling you want to create. And so I would not say there is like any right or wrong way to do this. It's as much an art as it is a science. So just take that for what it's worth right here at the top. I'm going to show you one approach. I'm trying to keep it as simple as possible. I will say this session is going to run long. In my run-throughs where I wasn't stopping to take any questions, it took about 70 minutes. And so I figure we're going to run for at least an hour and a half. Another thing that's going to be a little different about this session is that I am not going to be typing everything out live. I have like 4 scripts to go through, and so instead I've got commented versions of the scripts that I'm just going to walk through and talk you guys through on screen. So let me pull up a finished version of what we're going to create and show you guys an example. You guys should be now seeing the Unity editor. Somebody just give me a thumbs up to let me know that you can see that. And what I'm going to do is I'm going to play the scene, and I'm going to pause so that we can see in the scene view what has been generated here. So here we've got a 100 by 100 tile grid, which has had a number of rooms connected with hallways carved out of it. So if we zoom in, we could see the tiles are little sprites. And so we have these kind of rooms and corridors that, we could have our player running around in. And so this is the finished version. I'm going to take you through a little tiny bit of setup just to set this up in the 2D roguelike project, explain the idea of what we're doing, and show you a little bit of how the algorithm works, and then I'm going to start walking through the scripts. So put that up for a second, and let me change projects real quick to my empty one. All right, so here what we've got is a new 2D project, and I've imported the 2D roguelike asset package from the asset store. So in this project, we have a folder called completed. Now it's not going to have this 2D generation folder. I will post the scripts for you guys to grab with the archive, but for now, just sit back and watch. So in here, we've got our 4 scripts that we're going to use. What we're going to do is we're going to piggyback off of the completed scene in the completed scenes folder. So we're just going to go completed scenes main. And then there's actually a script in here that instantiates the game manager, the finished game manager that's in prefabs. I'm just going to keep it in the hierarchy just to make it a little easier to work with. So I'm going to drop the game manager in, and then I'm going to take off. So if we just look at, this is the way this game is as is, right? So it's a much smaller grid. We can move around, we can connect these pickups. And as you can see, the walls that are generated are just these kind of random shapes, right? They're not like rooms or corridors. And so what we're going to do is we're going to change this so we have a much bigger grid with these more kind of room-like level generation. And so what I'm going to do is I'm going to take this game manager and I'm going to remove the existing board manager script. So we're just going to remove component, and then I'm going to add my 2D generation board creator script. And there's some default values here. I'm going to start off using these. The first thing I need to do is plug in my floor tiles. So I'm going to use the prefabs in the completed folder. And what I'm going to do is I'm going to lock the inspector so that I can multi-select and drag these in. So I'm locking the inspector for the game manager, grab Shift-click to grab floor 1 through floor 8, and just drop those right on floor tiles. Boop. Grab the walls. Drop those in there. And then the outer walls as well. Don't forget to unlock the inspector once you're done. I've done that a few times on the stream where I'm like, I don't know why it's not working. Okay, so now we've got our board creator set up. If we hit play, and I'm actually going to, let's disable the sound manager. Let's just pull up the sound manager here. I'm just going to turn off the music and stuff just so I don't have to talk over it. Just deactivating those audio sources on the prefab so it'll instantiate, but it won't play. All right, so now when we play and pause, we should see, if we zoom out, yeah, we can see that our level is being generated, right? So the thing that I'm going to do, right now we have what looks like a sort of a moderately complex level layout with some interconnected rooms and stuff. What I'm going to do is I'm going to massively simplify this so we can understand how the algorithm is working and generating the rooms. So I'm going to exit play mode, take the game manager, and we're just going to go down to, I'm going to keep a high board size, so 100 by 100 board size, but I'm going to take the number of rooms. So here we can choose randomly between how many rooms, so a minimum of 15 rooms and a maximum of 20. And we can also set a range for the height. So a minimum of 3 tiles wide and up to 10 tiles, and a minimum of 3 tiles high and up to 10 tiles high. And then these are also connected by corridors that have a minimum length of 6 and a maximum length of 10. And we're going to spend a lot of time talking about this, so don't worry if it's not clear yet. What I'm going to do is I'm just going to set the rooms to, let's say, 4. So minimum and maximum of 4. The width is going to be 4, so we're just going to go 4s all the way down. So we're going to end up with we'll keep the corridor length the same. We're going to end up with a very simple little layout. We'll play our scene, pause, and there we go. So we can see what we're generating here is actually a linear chain of rooms, right? Here we can see they're all the same size. They're connected by corridors of various lengths. But so basically what's happening here is in our script, we're generating the first room, and the first room is always going to be quite close to the middle of the board, right? So here you can see it's almost exactly in the middle of the board, right? And then we're going to generate a corridor going off of it, and the corridor could be going either north, south, east, or west, right? In this case, it's going west. So we have a corridor going west, and then at the end of that corridor, we're going to generate another room, and we're going to repeat the process until we get up to our randomly chosen number of rooms, right? So here we lay out our first room, lay a corridor, generate another room, lay another corridor, this time going north, generate another room, and lay another corridor. Once you get up to the higher numbers of rooms, let's go up to, let's say, 40, we get these kind of more complex interlocking patterns because there's nothing in the script that prevents the rooms from generating on top of each other and overlapping. We do have some stuff to prevent it from just doubling back and forth on top of itself again and again, but it can go back to where there was a room and create a new one, and that's why we get some things like this. So here we can see we've got 2 rooms overlapping, right? And here are the 2 corridors going out of there. And I think that's pretty cool because it gives a more varied look to the dungeon. Like here we've got like a number overlapping together. But again, right, you can tune the tune the setup to your taste and to the needs of your game, right? You might like having a linear chain, or you might not, and that's up to you. And that's kind of the fun, or some levels you might want to be more linear, some you wouldn't. And that's kind of the fun of procedural content generation, is that you can, kind of tune the algorithms and get it to spit out stuff that's cool for you. As you can see, we're getting a little error down here. The game manager is trying to call a function to lay out the board on our board manager. So let's just get rid of that. I'm going to open the game manager and monodevelop. Whoops. And down here, we're just calling setup scene on the board manager script, which we have taken off that object. So I'm just going to get rid of that. And we should be error-free. You can also see that the player is being instantiate, or actually is not instantiate. The player's in the scene and is just starting down here in the corner, which is totally blocked in. At the end of the session, if we have time, I'll just write a little piece to place him in one of the rooms. Just remind me to do that if I forget, because that's not actually in the main scripts. Okay, so with that said, that is the kind of concept of what we're doing. And so now let's take a look at some of these scripts. So let's open up Board Creator. And so here, I'm just going to take you through, I'll take you through the variables and the kind of top level overview of what the script is doing. And then we're going to go look at the other classes, the room and corridor classes that are kind of the meat and potatoes of the generation, and then we will double back and finish Board Creator. So we're going to jump around a little bit. I would say just focus on the concepts. I'm going to make these scripts available for you guys to download. Don't try to copy them because they're pretty long. I'm just going to talk through. Okay, so the first thing that we have up here at the top in our Board Creator class is we have a public enum called tile type, and within it we have wall and floor. What we're doing here is we're going to build out a jagged array of the board and set within it each square to be either a wall or a floor as we do our board generation. And then at the end, we're going to loop through that array and actually instantiate it as tiles. So we're not working directly with the tiles to generate the rooms. We're going to do all of that inside an array. And then once we've calculated it all, we'll spit that array out as tiles. And so we're just using this enum to store just tile type, just saying this is a wall or this is the floor in the array, which we'll then read to create tiles out of. So here we've got a public integer called columns and a public integer called rows. This is just the vertical and horizontal dimension of the board. So right now our board is 100 by 100 tiles. Here we've got 4 variables of the type int range. And this is another class in the project that I'll show you guys right now. Basically what this is it's just a little helper class that we use to generate random numbers. So let's just open that up real quick. So here in int range, we have a public integer called minimum and maximum. And in the constructor, we can pass in the minimum and maximum and then access a public integer called random, which has a property saying anytime we try to get this number, return a random number between minimum and maximum, right? So, and in this case, because this is called random, we need to specify here that we're calling unityengine.random. And so we're using random.range, right, to give us a random number between minimum and maximum. So you'll see this a bunch of times. It's just so that we can avoid typing random.range, minimum, maximum, or width, minimum width, maximum width throughout our code. So it's just a little thing to make things more concise. So if we look at our board creator here, we've got 4 of those, right? So we have the number of rooms, which is a new int range that takes, so in the default is between 15 and 20 rooms, right? The width is going to be a new int range that's between 3 and 10 units wide. Height is going to be between 3 and 10 units high. The corridor length is going to be between 6 and 10 units long. Then we have those arrays that we filled. These are just arrays of game objects that store the prefabs we're going to instantiate between. We're using arrays because we randomize which prefab, like we have 8 different floors and 8 different walls. Strictly speaking, you don't need to do that. If you wanted to use one floor tile and one wall tile, you could just make this a regular game object variable. But it just makes it look a little more visually interesting. Here is the jagged array that I was talking about before. So this is an array of tiles, right? And so, or this is an array of tile types, right? And so here we're going to set the length of the array along each axis, right? And so theoretically, actually, these could be different lengths. In this case, we're doing a 100 by 100, and this is called tiles. And we'll see some more about how that works in a minute. We also have an array of rooms, which we're going to use. We're going to fill it with our rooms as we're generating the rooms for the array, right? So we have, this is an array of the class room, right? And we can open that up. And so in this script, we have all of the generation code for our room, right? So we say we want a new room, and then within that room, we're going to call setup room, which will generate the room based on the width and the height and some other things that we'll look at in a minute. We then have the same for corridors, right? We have an array of corridors that we're going to fill with corridors and generate corridors based on that. So here is our corridor script. And again, this contains all the logic to generate one corridor, right? We have a starting position, a length, direction, and so on, and we'll go through that in detail. Then we have a game object called board holder. This is just to transform. Let's just keep a little level up here so that we can see. And actually, let me just go for something much simpler so we can, let's go back to our 4x4 or our 4 room level. Okay. Well, that one's not so good. Double back on itself already. There we go. All right, cool. So zoom in on that. So as we can see, board holder just holds all of these tiles, right? We can see the grid of all the tiles. Board holder just keeps our hierarchy from looking like that, right? So we can see more easily. So in start, right, we're going to instantiate the board holder object, just make a new game object called board holder. We're going to call setup tiles array, which just creates our empty array, right, of tiles, our tile type array. Then we're going to create the rooms and corridors, right? And this is really where the magic is for this session, and we'll spend a bunch of time talking about this. Then we are going to set the tile values. So we fill our rooms array and our corridors array with room and corridor classes that have different sizes and lengths. And then we're going to go through and set the tiles in our tiles array to be either tile type floor or tile type wall, right? So we do it for the rooms, we do it for the corridors, and then finally we instantiate the tiles. So we take that grid of information about this is a floor, this is a wall, and we actually instantiate the prefabs. And then we have some little helper scripts to do that, just instantiate from array. This just uses the random, has some code to choose a random prefab from those arrays, and we'll go through that. But so basically, we're going to create the array, calculate where the rooms and corridors are, set the values in the array based on what we calculated for the rooms, set the values for the corridors, instantiate the tiles, and then we instantiate the outer walls, and the outer walls are just this border here of outer wall tiles that goes around the map. One of the things that's unique about this is these tiles are actually destructible. If you did the Scavengers 2D roguelike project, you'll know that the player can actually chop through these in 3 hits. So this is kind of like a hedge maze more than a dungeon. And so the outer wall tiles are not destructible, right? So the player can't leave the board. But obviously you don't need to use these assets or any of that stuff. You could just use this algorithm to make for whatever kind of game you want. Okay, so let's take a look. What I'm going to do is I'm going to walk through create rooms and corridors, and then we'll refer to the room and the corridor classes as we get to those functions that are called. Let me just look at the chat just to make sure everybody's doing okay. So another thing that I should mention here, guys, is that although this is called basic 2D generation, basic 2D dungeon generation, this does assume that you know a little bit of C# basic stuff. So I would probably classify the difficulty of this as more of a sort of intermediate level than a beginner level. So, you know, I see some questions in there. What's an array and stuff? If you don't know what an array is at this point, you're probably going to want to do a couple of our more basic tutorials before you try to tackle this. I'm assuming, you know, that you do have a little bit of stuff under your belt before doing this, because it is a little bit more, you know, a little more complex. Okay, so we'll just cover this quickly because it's easy. So the first thing that we're doing is we're setting the tiles array to the correct width, right? And hopefully as you grab these, you'll see we have pretty nice comments all throughout so you can follow along after the fact. So we're saying tiles is a new tile type array of width columns, right? Then we're going to go through the length of tiles and set each column to be another array of the length rows, right? So what we're doing is we're starting out down here in the corner, right? And we're starting with this. We're saying, okay, let's set this whole thing to be 100 long. And now we're going to start on this one and fill it in vertically along the y-axis to be 100 high, and then 100 high, and then 100 high. That's what's happening with these nested for loops. And when you're laying out grids and working with grids and stuff, this is a fairly common type of setup to see. Okay, and the good thing about, somebody was asking why use a jagged array? Well, if you wanted to have like a 50 by 40 board or 27 by 46, you could, because you could set the lengths independently. All right, so the next thing that we're going to do, right, calling from, so we call that, then we call create rooms and corridors, right? And this is where the generation is really happening. So the first thing that we're going to do is we're going to say our array rooms is going to be equal to a new array of rooms, right, of our room class using numRooms.random, right? And so you remember numRooms is an int range that already has its minimum and maximum set, in this case to 15 and 20, right? So if we say numRooms.random, it just means give me an integer between 15 and 20, right? So the number of rooms based on the default values here is going to be, we're going to get an array of rooms that's between 15 and 20 rooms long, right? Then we're going to do the same thing for corridors, but the corridors are going to be a new, so our array of corridors is equal to a new array of the type corridor, but we're going to use, for the length of the corridors array, the length of rooms, so rooms.length minus 1. And this is because we don't want to have corridors to nowhere, right? You can see here, we made 4 rooms, but we don't have like a corridor just sticking off here going nowhere, because we have 4 rooms and 3 corridors, right? So we use 1 less than the number of rooms for the corridors. Then we're going to create the first room and corridor. Now, the first time we make a room is going to be a little bit unique because it's not connected to anything. We're just picking a spot in the middle of the board, laying the first room, and then laying the first corridor off of that. So you'll see how it differs from the kind of main loop of creating the rooms and corridors as we go through. So what we're going to say is the first index in our rooms array, right, room 0, is equal to a new room. The first index in our corridors array is equal to a new corridor, right? Then we're going to call room, so we added a room to the array. Now, on that room that we added, we're going to call setup room, right? Now, when we call setup room, we're passing in some parameters, right? And so let's look at the function signature for setup room. Now, here we are in the room class, right? And it's worth noting that we have setup room, and then we have an overload for setup room. The only difference between these two is that the overload takes a corridor, whereas the first implementation doesn't, right? So the first time we call this, there's no corridor going into the room, so we can't pass in a corridor as a parameter, which we will do later, right? So this is only going to be used for the first room, as it says here in the comment, right? So we're going to pass in, it's going to expect, right, when we call it, an int range, right, which is going to be the width, an int range, which is going to be the height range, and then integers for columns and rows, which are just coming from the board creator saying, how big is the board that we're generating this room in? We're going to use that later to make sure that the rooms don't go outside the boundary of the board, right? And you'll see that a lot of the code that we're going to be doing here is going to be to do that, right? Because we're moving randomly. We don't want corridors or rooms that are going to extend beyond the space of the board. So this is actually really pretty simple. We're just going to say the room width of this room is going to be equal to width range dot random, right? So a random integer coming from width range, which was passed in when we created it, right? So board creator room width here. So in this case, it's going to be between 3 and 10, right? So now we're gonna let's move that out of the way. Now we're gonna actually I can close this for now. We don't need to look at that again. So we're gonna pick a number. We're gonna say, okay, room width is equal to 5, right? The height is equal to 6, let's say. Then we're going to set the X position and Y position of the room, right? And the X position and the Y position is up here is a public integer variable that's the X coordinate of the lower left tile of the room and the Y coordinate of the lower left tile of the room, right? So if we look at our map, let's look at, this is going to be our first room, right? Because it's closest to the center. So the rooms are always calculated from this tile, right? This is the position. This X and Y coordinate, in this case, 48, 48, is the origin for the room, right? And then we're going to build the room out based on that, right? So that's what's going to be stored. So for this first room, it would be, the X position would be 48 and the Y position would be 48. And we're calculating that by saying, take the number of columns in the board, in the whole board, and then we're going to take the room width, subtract, so 2f minus, so 2 minus the room width divided by 2. So all this is doing, the room width is a random number, right? So this is just creating, and we're doing the same for the Y position. This is just creating a little bit of random movement around the center, so it's not always just starting dead center. But basically, we're just putting the position of the room is always going to be roughly in the middle so that we have some space to move outward. In this case, it decided to head east to start, right? And so that's all we're doing for our first room. Now notice the next implementation of setup room is much longer because we now need to kind of worry about the edges and make sure that we're not going out of the edges. In the first room, we know, unless it was a room that was 100 by 100, we know it's not going to go outside of the bounds, so it's very simple, right? So if we jump back to board creator, we're calling setup room, right? Passing in the width and the height and the size of the board. And next, we're going to generate a corridor leaving that first room, right? So we're going to take the first index in our corridors array that we created, and we're going to call setup corridor on that corridor. Now notice, the first parameter that we're going to pass in is our room, right? So we created a room, and we're going to pass it to the corridor. So the corridor knows the room's position, And then we're going to pass in our int range for corridor length. So in this case, it's going to be between 6 and 10, right? Then we're going to pass in the room width and the room height. So the range, right? The int ranges for room width and room height. The size of the board in columns and rows. And in this case, the Boolean true, which is telling the corridor, yes, you are the first corridor. So if we look at setup corridor, we can see it takes a room, it takes an int range for its length, an int range for the possible room width and room height, the size of the board in columns and rows, and then this Boolean to check if it's the first corridor. So instead of using an overload here, we're just using a Boolean to say, is this the first corridor, yes or no? So in the first case, it's going to be true. So if we just look at our corridor class, right, we have up here at the top, we have an enum called direction, right? And this contains north, east, south, and west. So these are all the possible directions that the corridor can go in, right? And so next we have a public int called starting Exposition, right? This is the x coordinate for the start of the corridor, starting y position, which is the y coordinate for the start of the corridor length, how long is it going to be, and then again the direction, right? So we also have these two integers, end position x and end position y, which are going to calculate the end position based on the starting position and the direction. I'm going to come back to this. I'm going to come back to this later when we actually use it. So let's look at setup corridor because we're setting up our first corridor. So the first thing that we do is we say, okay, direction is equal to a random number between 0 and 3, right? Excluding the maximum, which is 4. So a random integer between 0 and 3, which we're going to cast to our enum direction, right? So it's worth noting with enums, you can flip back and forth between an enum and an integer, and we're actually going to use that aspect of enums quite a bit in this script. So we're going to say, okay, our direction is equal to a random integer, which we're going to turn into a direction. So one of north, east, south, or west, right? Now, this is a little bit tricky. You can see it has a long comment in front of it. Basically, what we want to make sure, if we look at our map, right, let's say we start here, and then our first corridor, in this case, is going east, right? We spawn a room here, and then we want to spawn another corridor. We don't want it to go back west immediately, right? Because what could happen is we go east, then we go west, then we go east again, then we go west again, and we end up with a dungeon that's just like covers this part of the board, right? There may be cases where you would want to allow this in your generation, and that's part of the kind of artistic aspect of deciding how you want to implement this. But in this case, we wanted to make sure that it was going to keep going and spreading out, covering more territory instead of doubling back on itself. So what we're doing is we're calculating the opposite direction of the direction that we came from, right? So we're going to say, okay, we have a new direction, a new variable of the type direction called opposite direction, and that's going to be equal to the room entering corridor direction, right? So remember, we took a room as we called the function, and so we're going to say, okay, room has this public direction variable entering corridor, which stores the direction of the corridor that came into this room, right? So if we look here, so here's our first room. So when we're generating this room, or the corridor leaving this room, right, the entering corridor was coming from the east, right? So we're going to say, okay, let's say if the entering corridor was east, we're going to add 2 to it. So we're going to cast it to an int, right? And then we're going to add 2. So what happens to our enum if we start with east and we add 2, we get west, right? And this is an important aspect of the way this enum, so normally people would say north, south, east, west, right? We're set up north, east, south, west so that we have this relationship between our directions. So if we add 2, we invert the direction. And if we add 1, we're going to turn perpendicular to the direction we were, right? So here, we're adding 2 to get the opposite direction, right? And then we're using the modulo operator here, the remainder, right, to say, okay, if we were on west and we added 2, we would end up with 5, right, which is not part of our enum. So instead, by saying, okay, we get 5, but then we divide by 4 and take the remainder, we get 1, which is east, right? Because this is 0, 1, 2, 3. So this kind of construction of using modulo can be useful when you have either arrays or enums or lists where you might want to do some mathematical operation, but you don't want to exceed the length of your whatever you're working with. So then we're going to cast that back to a direction, right, and store it in opposite direction. Then we're going to check if this is not the first corridor and the direction is opposite direction. So we've got the situation where we've generated a corridor that is trying to double back. What we're going to do is we're going to declare a new integer called direction int and set it to equal our direction, right, which was the random number that we created up here, the random direction that we created as an int. And then we're going to add 1 to it, right? So if we had east, like we do in the example, and we're trying to go west, now we add 1 and we get north, right? So we're going to turn perpendicular to the direction we were going by adding 1. And then again, we're just going to say, okay, direction int equals direction int modulo 4, right? Meaning to make sure we don't get a 5 or a 6 or I think those are the, well, no, a 4 would be the only possibility, right? Because we're just adding 1. Make sure it doesn't overflow. Divide by 4 and get 0 back to north. And then we're going to say direction equals direction int, right? So basically, we're just saying make sure that if we did generate a direction going back on itself, we're going to instead we're going to turn. Okay, then we're going to generate the corridor length, right? So the corridor length is going to be equal to length.random. This is coming from corridor length, right, which is getting passed in to set up corridor, right? Here it is. And so basically we're just saying, okay, this is going to be a random integer between 6 and 10. And now we're going to do all of this stuff just to make sure that our corridor does not go off the board, right? So if you didn't care about going off the board, you could ignore all of this, right? You could just generate it purely randomly, wouldn't matter, right? But in this case, we want to make sure our corridor doesn't go off the board. And so what we're going to do is we're going to say, okay, we're going to create an integer. We're going to declare an integer called max length. And that is going to be equal to the max property of our length int range, right? So the max length cannot be longer than the maximum possible length specified here, right? So in this case, it's 10. So the max length is going to be equal to 10. And then based on our direction, we're going to modify its possible positions, right? So let's just go over north. So if the direction is north, the starting position can be random, but within the range of the room, right? So let's look at this. This one is going north, right? So we could choose from, if we're going north, we could choose from any of these along the x-axis, right? We don't mind which, and actually it's kind of cool if it's in a different place, right? As opposed to just being from the middle or always being from the edge, right? It could be any of these 4. But the starting y position is going to be the y position of the room plus the room height, right? Meaning it always has to be in this row, right? So we're going to, here would be the starting Y position is here, right? We're going to add the room height to get to this line of spaces, right? So we always want it to start from the top of the room if we're going north. If we're going east, we always want it to start from the east side. If we're going west, we want it to start from the west side. If we're going south, we want it to start from any space on the south side, right? Then we're going to say the max length of the corridor is going to be equal to rows, so the total size of the board, minus the starting Y position, minus the minimum room height, right? So as we can see in the comment here, the maximum length the corridor can be is the height of the board, but from the top of the room, right? So we just want to make sure that this is not going to go off the board. And so we're checking where is it starting and making sure it's not going to exceed the length of the board. Now, at the point that we're at now, right, we would need a 40 unit long corridor. But once our thing wanders over to the edge, this does actually become relevant. And so we need to control for it, right? We're doing almost exactly the same thing in each of the other directions, but in this case, right, the X position, if we're going east, is fixed, right? It's always going to be on this side. And the Y position is going to be the one that could be randomized, because it could be one of these four squares as long as it's on the east side, right? Then finally, we're just going to use mathf.clamp, right, which clamps a number between two values. And so we're going to say corridor length is what we want to clamp. It can't be shorter than 1, and it can't be longer than max length. So just making sure that our random number that we generate doesn't end up bigger than we possibly want it to based on the calculations in this switch. So that's our corridor, right? So what we're doing here is we are generating that first corridor and telling it, yes, this is the first corridor. So we're going to, in fact, right, we'll skip over this. It is the first corridor here, right? So we're not going to do any of this, but I just go through all that so that we're done with the corridors. So that now, when we move on to the next part of our function here, so once we've set up the rooms and corridors, now we're going to run a loop over the length of rooms.length. So if rooms.length is 10 rooms, right, we chose to create 10 rooms, we're going to run through this loop 10 times. And notice we're initializing the loop to 1 because corridor 0 has already been set, right? Room 0 and corridor 0 is already set because we set it up uniquely for the first room. So now we're going to say, okay, rooms 1, right? Since we'll kind of walk through the first iteration of the loop, and then the rest are going to run the same way. So rooms 1 is a new room, right? So we're adding a new room to the array, and then we're going to call setup room on rooms 1, passing in room width, our int range room width, our int range room height, columns and rows for the size of the board. And now we're going to pass in a corridor. And we're going to pass in corridors I minus 1. So right now I is 0. I'm sorry, I is 1, right? We initialized I to 1. So we're going to pass in corridor 0, which is that first corridor that we created. So we're always going to be working from the new room is going to take the direction of the corridor that we just created in mind, right? Because it's going to use it to generate the room. So let's take a look at our more complex setup room overload here, which takes, as we can see, a parameter of the type corridor, right? The rest is the same. We have the width range, height range, columns and rows, but it also takes a corridor because now all the rooms that we generate are going to be coming off a corridor. Okay, so the first thing that we do is we say entering corridor, right? The direction for our room is going to be equal to the direction of the corridor that we passed in, right? So corridor.direction. So in our example here, here's our first room. Now here's our second room. So the entering corridor was going east. So entering corridor is going to be equal to east. then we're going to set random values for the width and the height, right? So the width range is going to be random and the height range, so we're using the int range again to get random numbers for each of those. And remember, I'm using 4 by 4, but obviously you could have 2 by 10. You know, you can have a wider, you can make rectangles and long skinny rooms and stuff depending on the values you put in. I'm just doing squares because it's easy to look at. Then we're going to do this guy. And this is very similar actually to what we did in Corridor, where we have a switch that takes the direction, right? So, and I kind of skipped over what a switch is. A switch just says, it's like a bunch of if statements, but it's just a little cleaner than that. So here we just say, okay, the corridor direction is what we're checking. If the corridor direction is north, do this stuff. If the corridor direction is east, do this stuff. If the corridor direction is south and west, etc. Right? So it's just a little bit of a, if you find yourself writing like 5 if statements, you might do better with a switch, right? I remember when I learned that and I was like, oh my God, life was better. Okay, so if the corridor entering this room is going north, we're going to say the room height. So we want to make sure we're going up, right? We're going north. We want to make sure that the room is not bigger than the size of the board, right? So the room height is going to be equal to mathf.clamp. So the value we're clamping is room height. Can't be less than 1, but it can't be more than rows minus corridor.endPositionY, right? So here's where we're using that end position y. So let's jump back to our corridor for a second to see what that's doing, right? So basically we're just making sure that we're subtracting the end position from the total number of spaces in the board to make sure that the height cannot be greater than the size of the board, right? So in corridor, these are just integers, right? But we're using a property, so whenever we get them, it's going to do some calculation. So here, we'll look at end position y since that's what we were looking at. So if the direction is east or west, the end position is going to be the same as the start position, right? Because the corridor is moving like here, it's moving vertically. The x coordinate never changes, right? So we're just going to return the start position, right? So the x position changes, the y position never changes. I misspoke. So the y position never changes, so we're just going to return the start position is going to be, the y coordinate is going to be the same. If the direction is north, we're going to return the starting y position plus the corridor length, and then we're just subtracting 1 to get this guy, the length, the last tile in our corridor, and then we're going to create the room at the end of it, right? Finally, if it's neither east nor west nor north, right, so all of these if statements pass through, then it must be south, and so then we're just going to subtract along the y-axis, right? So we're going to take the y position, subtract the corridor length, and we're going to add 1, right? So basically we're just going to count down and then add 1 to get us back here. Okay. And then we're doing the same thing on the x, right? We're checking if now, instead of checking if we're going east or west, we're checking if we're going north and south, and then we're going to return the same x position. Otherwise, we're going to check if we're going east, and then we're going to add the corridor length, right? Going this way. And then otherwise, if we're going west, we're going to subtract going this way, right? Okay. So here, we're using that to check and make sure that we're clamping the height of the room to be less than the number of rows in the board minus the end position of the corridor. So the y coordinate of the room must be at the end of the corridor, since the corridor leads to the bottom of the room. So the y position of the room is going to be equal to corridor.endPositionY. And then the x coordinate can be random, but not outside the width, right? So the x position is equal to random range corridor.endPositionX minus room width plus 1, And so that's the minimum value, right? And then the maximum value is going to be corridor.endPositionX, right? So we're just basically going to we're going to place, let's say here, right? We're going to place this tile, which is the origin position for the room, based on, because we're moving north, we can randomize it, right? And so we can kind of wiggle it back and forth a little bit, but not obviously more than the width of the room, because it would not connect, right? And then finally, we are going to clamp it to make sure it doesn't go off the board, right? So again, we're using exposition. Exposition equals mathf.clamp. The value we're clamping is exposition. It can't be less than 0, and it can't be greater than columns minus room width. Yeah. And then we're doing the same thing along the other directions, right? So in the case of east, we are saying instead of checking the height, instead of setting the height, we're setting the width, right? And we're doing the same thing, but for the X position, basically just rotating what we were doing, but using basically the same structure. So, and that is actually, as far as the actual procedural generation stuff, that's basically it. Now, once we get over here, there's kind of a bunch more housekeeping stuff that we have to do to actually lay it all out. But in terms of generating the shapes, that's done it. So, and as you can see, right, most of the time we're spending is just trying to make sure stuff doesn't go outside the board. So it's not crazy complex. It's just, you just need to make sure that you don't just generate a bunch of garbage, which is always the risk with random generation, right? You got to shape that randomness and control it and kind of keep it in a bottle. Okay, let me look at the chat. Oscar Russo asks, also, how do you ensure you have no overlapping rooms? In this, we are not checking for that. We have overlapping rooms in this, and I'm actually calling that a feature, not a bug, because that allows us to have more interconnected dungeons that look a little cooler by overlapping, and also like irregular shaped rooms. If you didn't want that, you would probably want to use a different approach. Yeah. So that's kind of like the fun part, right? And then, so basically we've called setup room, right? Which I just walked through. And then we're just going to loop through corridors.length, or we're just going to check if I is still less than corridors.length, we'll make a new corridor and call setup corridor on it, right? Which we went through. So as long as corridors.length, right? Remember, corridors.length is 1 less than our number of rooms, we'll make a new corridor. Once we run out of corridors, we'll stop making corridors. Which is pretty sensible, right? Okay, so now we're just going to set the tile values for the rooms, right? So now we're going to set the values. So right now, all of this stuff is just living in our rooms array and our corridors array, right? It's not actually on the grid yet. It's just a bunch of numbers in these two arrays. Now we're going to actually spit that out into our jagged array tiles, right? So now we're going to do a for loop over the length of rooms, right? So we're going to loop through the rooms array that we created to get all the rooms. And we're going to declare a new room called current room, and that's equal to whatever room we're at in the rooms array. And then we're going to run a for loop on that and go through its width, right? So we're going to say int j equals 0, j is less than the current room's room width, right? Then we're going to iterate, right? So we're going to say the x coordinate is equal to the current room's x position plus j, right? And then we're going to go, so we're going to go basically one at a time, right? So let's say we take this room. We're going to have, first of all, we're going to set the derp, if I can click on it. We're going to set the x position, and then we're going to loop up along the y-axis and set the y position of each of these before we move to the next x position, right? And that's what these nested, the loop inside the loop, are doing. So then we have another loop here that goes along, as long as we're less than the room height, that goes along the y coordinates and sets y position plus k, finally takes both of those values, right? Takes both of these, the x coordinate and y coordinate, and sticks them into our tiles array and sets that to be a floor, right? So it's looping through all of the rooms and setting their tile type. Remember this enum up here, right? It can be either a wall or a floor. And so it's looping through all of those, all of the rooms, and setting the tiles within the bounds of each room to be a floor, right? And if you're not used to this structure of these nested for loops to kind of loop over a grid, it can be a little counterintuitive, but you can just imagine that we're just going one column at a time and going up to the top before we move to the next column, right? So we just say, take this one, fill all these, take this one, fill all these, and so on. Okay, so we've recorded we've set floors for all of our rooms. Now we're going to do it for our corridors, right? And we're doing very similar thing. Now we're going to loop through the corridor's length. We're going to say the current corridor is wherever we are in the loop. And then we're going to go through its length. So another nested for loop, right? We're going to say the current corridor. So as long as j is less than the current corridor's corridor length. So we're going to say the start coordinate in the tiles array. Well, we're declaring a new integer called the x coordinate, right? Which is what we're going to stick into the array eventually, is equal to current corridor dot start x position, and the y is equal to start y position. Then, depending on the direction, we're going to either add or subtract from that, right? So let's say we're going north. We're going to take the y coordinate. We're only going to modify the y coordinate, right? Because the x can stay the same. And we're going to say y coordinate is plus equal to j, which is wherever we are in the loop, right? So, and then we're going to do, for east, we would add to the x coordinate. For south, we would subtract from the y coordinate. And for west, we would subtract from the x coordinate, right? Finally, when we end up with those numbers, we stick them into the array again. So tiles x coordinate and y coordinate are equal to floor, right? So now what we've done is we've set in our array all of the room shapes to be floor, and now all of the corridor shapes to be floor, right? We haven't created any tiles yet. This is all just inside this private array of enum. Okay. Then, now, right, in start, sorry, a lot of zipping around there, we're going to call instantiate tiles, right? Now we actually are going to turn them into prefabs. So now we're going to call instantiate tiles, right? And we're going to say, okay, again, same nested for loop structure. First, we're going to loop along the x. So for the first x position, we are going to, so here we're just calling tiles.length, which is the length along the x, right? Or the first dimension of our array. And then int j equals 0 for as long as j is less than the length of our second coordinate at I, right? So again, we're going to go through all of these. We're going to start at 0, right, and work our way all the way to the top, and then we're going to go to 1 and go up, right? So we're doing this kind of a educational mouse waving. This is what I do for a living. So wave the mouse around. It's going up, up, up. Okay. So that's good, right? Are you not educated? So we're going to loop along, and then we're going to call this instantiate from array function, and on instantiating from our floor tiles array. I'll talk about instantiate from array in a minute, but it's simple, and basically it's just picking a random prefab from our floor tiles array here. Just picking one of these and instantiating it. Now, and that's just so that we can have, if you look at the floor tiles, right, you can see they're all different and they look brown and pretty. Thanks to our artist Pete Lee at Pete Earstrike on Twitter. Excellent art maker. Okay, so now the reason that we're placing everything gets a floor, and that is because we can destroy the walls and then we need a floor to be underneath it, right? So if you didn't have that capacity to destroy the walls, you could just say, if the tile type is floor, put a floor, otherwise put a wall. In this case, we know we need a full grid of floors, but we're going to check if the tile type is wall, we'll put a wall as well on top of that floor, right? And obviously for the ones that we've tagged floor during this process, it won't put a wall there, and then we will end up with our actual board. And then we're going to call instantiate outer walls, which is super simple and just lays out, basically just goes up that way. It makes that sound while it does it, and then down the side and lays out the outer walls, right? And so here it's just we have left edge, right edge, bottom edge, top edge, and then we're just calling instantiate vertical outer wall, which just loops from the starting Y and then goes up, 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 calling instantiate from array along the Y, right? So just moving up, making tiles. Do the same thing for horizontal. And then instantiate from array just takes a array of game objects as an argument, right? Called prefabs. And then the X coordinate and Y coordinate to instantiate at. It generates a random number within the length of the prefabs array, creates a vector 3 called position using X coordinate and Y coordinate, and then instantiates it, right? So makes tile instance equals instantiate prefabs using that random index, right? So a random number inside that array using the position that we just created. Quaternion identity just means no rotation as game object. And then we set the tile's parent to the board holder, right? Just so that we can do that. And that, my friends, is how levels are made. At least weird 2D dungeon hedge maze levels in this part of the universe. But hopefully that's been helpful for you. For those who are new, thank you for joining us. For the regulars, thank you for coming back. And I am going to hang out in the chat and answer further questions related to this, please. I'm not going to be fielding other questions because we got 250 people in the chat and we got to keep it on topic tonight. And thanks to Adam Buckner and Mike Geig for joining us. And thanks to you for watching. Jeffred Luigi asks, can you answer my question? What would be a good way of spawning monsters, treasures, game objects in the rooms? Well, what I would do probably is add that to the room generation code. So we would add to our enum, a monster prefab, add an array of monsters, and then just as we're generating the room, give it a chance to stick a monster in there, along with the treasure and whatever else. Not too hard, I don't think. Kuno Nuoni, thank you. I'm glad it was engaging and motivating. That's what we hope to do here. All right. Yeah, I mean, I think basically, right, once you've got I would probably just make the monster generation a part of your room generation, right? Or at least you could have a monster generator script, right? And just call that, let's say you could just choose X number of tiles in the room, and instead of turning them into a floor, just instantiate a monster there. Oh, yes. Okay, thank you, Kuno Noni. There was something I was supposed to not forget to do, which was to add to this the ability to spawn the player, right? So you guys can actually test this and walk around. So Okay, so what we're going to do is we're going to jump into the board creator, and we're going to add a public game object player. Boop. And we're going to make the player into a prefab. So I'm just going to grab the player from the scene, drop him into the prefabs folder to make a oh, we had one already. Okay, actually, there's one thing I need to do. Wait, let's delete that. Let's take this guy. Whoa, that got messy. Okay, we need to child the main camera to the player. The main camera in the original project has this loader, which enforces the singleton pattern for the game manager. What I'm going to do is I'm just going to make a new game object called loader and just add that loader to it instead. So, and then we'll put the game manager and the sound manager in there. This just checks if we have a game manager and a sound manager and adds them if we don't. And that means we can now take it off the main camera. So I'm going to remove component loader on the main camera. I'm going to child the main camera to the player, right? So that the camera will move with the player. And that should be good. We just and then make sure it's not offset, right? Let's center it on the player. Whoa, oh, don't change the Z depth. Should be -10, right? And then, whoa, did the player get broken? Is he still there? Oh, it's the animation. That's why. Oh, and I'm doing this all in pause mode. That's dumb. Gosh, I always do that. I need to put my play mode tint on. Every time I upgrade the editor, I forget to do that. Okay. Anyway, this will be fine. We'll call this player explore. This is all stuff that's just specific to this project, this implementation in this project. So you don't, strictly speaking, need to do this, but that's kind of fun. So, okay, then on the game manager, we're going to add the player explore to the player field that we created. And we'll delete the player from the hierarchy. I'm going to save this as, let's save the scene as, oh, I can't because I'm in play mode. Okay, delete the player. And I lost my loader object. Derp. Okay. This is what I get for trying to do things fast. And this will be main revise. Okay. And then let's just make sure, yeah, we got to put this on there. Put the player explorer in there. Save. And in the script, it's pretty simple. All we're going to do is when we're creating the rooms, I'm just going to say in this for loop, as we're looping through the rooms, I'm just going to add a little quick check to say if rooms I equals oh no, sorry, not if rooms I, if, oh, I'm losing my mind. I have this long hours of talking. So if I equals rooms.length, let's do times 0.5. So basically, to get, as we're about halfway through, we're just going to say instantiate player at room, I'm trying to remember, I should have wrote this down, rooms I dot exposition. Oh, we got to make a position, right? Hold on. Vector 3 player position equals new vector 3. So you got some live coding after all. Rooms I dot x position, rooms I dot y position 0. So we're going to instantiate player at player position and quaternion dot identity. Okay. It's an F. Hopefully that works the first time. Let's find out. That's set. Game manager is there. should be fine. Yay! Oh, there's 2 audio listeners in the scene. I didn't delete the camera. Let's delete the camera. Get you out of here. Let's make sure it works. Okay. Well, I've got some error. But anyway, as you can see, the player is now instantiated midway, roughly, in our chain, right? You could have him instantiate in the first room or the last room if you want to have him start at the end. Because our dungeon generator kind of trends towards making a linear chain, I figured putting him in the middle, then he has to choose which way to go to start might be more fun. What error am I getting? Something. Oh yeah, it's missing a reference to something. I remember I had to fix this before. Oh yeah, the food text. You just have to find a reference to the food text. You just do like GameObject.find or do it some other way. But anyway, that's the relevant part here is just instantiate halfway through the loop or at the end of the loop or the beginning of the loop, but just drop the player in there and then he'll end up in a room. All right, cool. Yeah, Adam pasted the Rogue Basin link. That's a great place to find more about this stuff. Cool. All right, guys. So what I'm going to do is I am going to cut my mic off and cut the stream, but I will hang out in the chat for a little while longer and continue to answer some questions if you have them. And yeah, thanks for watching.